All right, doing stoichiometry, there are three methods I know, so if this method does not work for you, watch one of the other videos. This is doing stoichiometry by step methodology, which really means that there are 3 steps to stoichiometry. Your first step is always going to be, sorry, let me try that again. Your first step is always going to be to find the number of moles. Now the great thing about this step is that you sometimes can skip it, especially if you're given moles to start with. Okay? So step 1 can be skipped. Step 2, however, is never skipped when you're doing a stoichiometry problem. And that is to change from moles of what you're given to moles of what you want. And it's always going to be set up in the form of what the question asks for over what the question gives you. It's always going to get set up that way. So you take your number of moles and you multiply it by this ratio. This is called the mole to mole ratio. It is always what you want over what you are given. So in this first problem, we are given sodium silicate. We want hydrofluoric acid. So it would look like this. HF over, if I could do this correctly, there we go, over sodium silicate. Always, always, always what I want over what I'm given. That's the hard part. Step 3 is like step 1. If you're asked for moles, stop there. There's no reason to go any further. If you're asked for a different unit besides moles, you are going to go to step 3, which is change moles to, I think I spelled that wrong, desired unit. And to do that, you're going to use your mole table that we used in the other videos. These are the 3 steps. Okay? If you can keep those 3 steps in your mind while you do stoichiometry, it shouldn't be a breeze. It's only 3 steps. It's all you have to do in order to do stoichiometry. So I'm going to keep this off to the side here and try not to erase it. We'll work on these problems. So, how many moles of hydrofluoric acid are needed to fully react with 0.3 moles of sodium silicate? When you're doing the step method, when you're doing this method of solving stoichiometry, it sometimes is very helpful to underline the units you have. How many moles? This is what it wants to know. How, with this many moles. Okay. So I already know that I'm going from moles to moles. I don't need to do anything really special. So find number of moles. Check. Number of moles is right there. 0.300 moles of sodium silicate. Nah, those other zeros are unnecessary for right now. Stay spaced. Otherwise I'm going to run out of it. All right, I'm going to multiply this by my ratio, right? Because we can skip step 1. Check, we're done with that. Step 2, change moles of given to moles of want. And it always goes in the format of what I want. What do I want? I want HF, hydrofluoric acid. What do I have? I have sodium silicate. Okay? We use the coefficients here. The mole to mole ratio is the coefficients of each one of these. So HF, number in front of HF is 8. Number in front of sodium silicate, there's no number. What does that mean? It means it's automatically a 1. So I pull up my calculator and I type in 0.3 times 8 divided by 1 and I get 2.4. 2.4 moles of, we got rid of this, we got rid of that, so it's HF, moles of hydrofluoric acid. Check. Change moles to desired unit. So what unit were we asked for? We asked for moles. So I need to change this. So we're done with that too. So we are actually done with this problem. All that's left is to check our sig figs. I see 1, 2, 3 sig figs. So 1, 2. I need one more sig fig, so we'll add a 0. Pretty simple, especially when we already have a number of moles as one of our givens. So let's come down here to one that's a little more complicated. How many grams of water can be produced from the complete reaction of 0.8 grams of sodium silicate with excess hydrofluoric acid? So it's not a limiting reagent problem. It's just straight up, can you do stoichiometry? So I see 0.8 grams. Let's put that up here because I like to keep track of things. 0.8 grams of this. How many grams of water? So grams of water is what I'm searching for. Okay, this one's a little more complicated because we're not given moles off the get-go. So we do have to do step 1. Find number of moles. I have 0.8 grams of sodium silicate. I need to figure out how many moles that is. So I multiply. Sorry, I divide. See, look, even I can make mistakes. I'm going to divide by the molar mass. Because in order to go from grams to moles, we have to divide by the molar mass. So molar mass of sodium silicate. I have 2 sodiums, I have 1 silicone, and I have 3 oxygens. So that's 2 times 23 plus 20. Look at my periodic table because I don't have it off the top of my head. 28.09 plus 3 times 16. Pull up my calculator again. Two times 23 plus 28.09 plus 3 times 16. Molar mass is 122.09. That's what all this is. All right, so I'm going to divide 0.8 by 122.09. 0.8 divided by what we just got, and we find that that is 0.06553. Now notice I kind of truncated that number, but I did so after the correct number of sig figs. You want to avoid rounding errors, so I'm actually not going to erase my calculator. I'm going to go back into my calculator and use the number directly off of the calculator so that I retain as many of those digits as possible. If I had just said 0.065 and then used only that number in my further calculations, I'm going to get a wrong answer. My rounding is going to cause me to have issues. Okay, so we're done with step 1. Step 2, change moles of given to moles of want. So I'll do a different color, let's do green. To do that, you multiply by the ratio of what you want to what you're given. So what I want is water. What I'm given is sodium silicate. So again, it's the coefficient. Coefficient in front of water is 3. Coefficient in front of sodium silicate, no number, so that means it's a 1. So I'm going to take my answer that's in the calculator, and I'll multiply it by 3 divided by 1.
3 divided by 1?
And I come up with 0.01966. 0.666 moles of water. That's not what I have. Again, remember, do not empty your calculator because we're going to use the number directly from the calculator. This is just for my record so I know where I am. So now we're done with step 2. Last and final step, change the number of moles into the desired unit. My desired unit is grams of water. So I need to take this number of moles of water, and I need to get grams of water. In order to do that, I multiply, sorry, this is a bit of a mess down here. I multiply by the molar mass. Molar mass of water is, I'll put it off to the side here, 2 hydrogens on 1 oxygen. Hydrogen is 1, oxygen is 16. 2 times 1 is 2, plus 16. So I'm going to multiply this whole number by 18. When I do that, pull up my calculator again. Woo! Falling over. Times 18. I come up with 0.3538. 0.3538 moles of water. All right. All that's left is to check my sig figs. I see 3 sig figs. 1, 2, 3, 4, 8 pushes that 3 up. And my actual answer, if I can find a place for it, I can put it over here. After I move this. My actual answer is 0.354 moles of water. All right, 3 steps. Find number of moles. Use the mole-to-mole ratio. Change moles to something else. It's always going to be, not always, I'd say 98% of the time, it's going to be a divide, a multiply, and then a multiply. Okay? Divide, multiply, multiply. Trick is remembering what to multiply by, what to divide by.